Another thing we will now take a look at is how to monitor and troubleshoot IAM. We will start with an overview of a suite of tools collectively known as Policy Intelligence, and then we will take a look at the first two of the tools. This is going to be Policy Analyzer and Policy Troubleshooter. Policy Intelligence is a suite of tools that are created to help us analyze, optimize, and improve IAM policies. Think about any type of large organizations that have a lot of resources deployed in the cloud with a complicated hierarchy, tens of thousands of users, large number of service accounts, generally a huge number of resources. Think about managing an IAM policy within an organization like that. It brings a lot of things to look at, and it makes it really hard to just look at the IAM policy, allow policy configuration pane, for instance, to figure out which principal is going to have access to what resources at what level. And because of that, in those larger environments, or generally just to speed up the overall troubleshooting process, you may want to use a bunch of tools that will help you figure out what type of access your principals will have, how access rights will change when you modify the policy, and also help you with overall configuration of IAM policies. In summary, we can say that these tools will help us with insights, recommendations, and overall troubleshooting of IAM-related configurations. They will be able to identify over and under permissive policies, let us know about possible changes to be made, and all of this is supported by machine learning and some AI functions. The Policy Intelligence Engine is going to look at the historical data, at the logs in our organization, at the access patterns to better tailor the responses to give us more meaningful insights that fit into our organization. Overall, this is another great tool that will help us better align with the principle of least privilege. It's something to keep in mind when you work with IAM policies in a large organization. Policy Intelligence is made up of four main products. We've got Policy Analyzer, Policy Troubleshooter, there is also Policy Simulator, and IAM Recommender. In this session, we will take a look at the first of these two products, Policy Analyzer and Policy Troubleshooter. We're going to start with Policy Analyzer, which is designed to analyze and audit IAM policy bindings. This is something that we will use to determine who, which is going to be the principal, has what access, so what type of roles and even permissions, to which or resources, or basically where within the organization. And as we will see, this feature is gonna give us information about the full binding. So we will see the exact principal with the exact role assigned, in addition to the resource or resources where this binding applies. One thing to bear in mind is that Policy Analyzer only supports the allow policy. This is actually because allow policy uses role bindings. So this is not something that you will be able to, let's say, tell what access is blocked or denied. We've got another tool for that. Policy Analyzer is going to help you figure out how your bindings look like across the organization, or maybe within a certain project, so at certain level within the organization's hierarchy. It also automatically accounts for policy inheritance, so it is going to tell you about the roles, permissions inherited from the parent levels, and of course about the roles and permissions assigned at the, let's say, project level or wherever you run the analysis. Okay, this feature also supports some basic checks for that you can run for service accounts. This is mostly to check the activities related to the service accounts. Like for instance, take a look at the service key usage, or maybe when service account was used for the last time. You guys don't forget to subscribe if you like our content. Thanks! Okay, some use cases for Policy Analyzer. Which principals can access this resource? This is obvious, like when you want to figure out who can access a given resource in the organization. I would also use it to see which resources can a given principal access, so kind of like the opposite. We can also check which principals, so who has specific roles or permissions. And another use case is like when you want to see exactly who has access to what at which level. That's some of the examples of how you could use this feature. Let's now take a look at this under IAM and Admin Policy Analyzer. As you can tell, the two options we have available here is to either analyze our IAM policies, or the other one is to analyze organization policies. Organization policies is something separate from IAM, allow, deny, PAB policy. Think of this as of a bunch of settings you can enforce across the entire organization. Like for instance, to block service account API key bindings, maybe block compute engine preview features. As of right now, we've got 153 different settings that we can enforce across the organization. Okay, but going back to the analyzer, we will take a look at analyze policies. Notice that when you are not paying for the premium license, you can run up to 20 queries per day. So 20 queries per 20 queries per day is the upper limit at the free tier level without buying a license. Okay, this analyze policy section, it comes with a bunch of templates for different use cases, like common use cases for policy analysis. You can certainly build a custom query where you specify the different options one by one. But for instance, if you want to take a look at a specific use case, like for instance, who can change IAM permissions for service accounts, projects, you can create a query from here. Maybe who can impersonate a service account. Maybe let's take a look at first and foremost what. First, let's now maybe let's look at how to build a custom query first. Okay, so I can specify the query scope, organization, folder, or project, so level of the hierarchy here, and then I can specify a parameter up to, I believe, 10 options for each of the type. So resource, principal role, or permission. It says add up to 10 roles and permissions in total. 10 roles and permissions in total. And then we can specify a principal and a resource. There is also some advanced options. Maybe first let's take a look at like when we specify, say we want to see the bindings for a principal Kate at cybrec.com. But for this to work, I need to switch the project because Kate has access to the dev project only. Yeah, let's see, continue. Advanced options we have available here for this query. This is first to list resources within resources matching your query. It says when you specify a resource as a parameter, this option will include all applicable resources belonging to your specified resource in the query results. When you don't specify a resource, this option will include all applicable resources belonging to the resources matching your query requests. So do you want to expand on the resources or not? And the other one is list permissions inside roles. Do you want to expand on permissions inside of roles? No, I don't. We will just say analyze. And we will run the query and take a look at results. Okay, so this is a really simple output because we have just one binding here. It says that Kate, our principal, is granted the viewer role on the dev project resource. And this is inherited from the dev project, this binding. We can say, show me the binding here, a simple JSON output, a single role, and associated principals. This is a single user account. You could also use this feature to take a look at the policy changes. Like the green stuff is going to tell you what was added versus something in highlighted in red means that it was removed. You've got different timestamps. You can take a look at the changes at different times. So like the good for really good for auditing. Okay, maybe let's also go back and now choose the what roles does a specific user have on a given resource. Use a template inside of the training project, and we will, as you can tell, the difference is that the fields are now pre-configured for you, the parameters I should say. We will look at this for TAD, and we will look at one of the instances, let's say training instance 3. Just make sure to select an instance and not, for example, a disk, which comes with an instance here. So this is a full path to the resource. This is an instance. And we will now continue. And maybe this time let's list resources within resources matching your query and analyze. Okay, so this time they tell us that TAD has the viewer role assigned for this instance. This is the first binding. And then actually this is for the group. So TAD is a member of the group SecOps, and that's why he is listed here. And the other binding also for the group is for the compute instance admin version 1. Okay, so in this case, we didn't really have other resources to see. Maybe let's also take a look at the service account. This template is gonna show us who's able to impersonate or also use a service account. The IAM service accounts act as permission is something that's needed to use the service account. Okay, so we will run it for a training project. Across the project, we will continue. And first we will run without listing individual users inside groups and without listing other resources to see what is going to be the output. We've got a bunch of bindings. We see that the group SecOps has access to the VM storage access, custom service account, and the role specifically to access this resource that is granted to the principal is service account user. We can take a look at the binding. This is for the group. We can also tell that this default service account has the editor role assigned on the training project. And there is also GCP admin at the bottom here, who's the owner of the project because he created the project, which includes this permission. Okay, what is going to change when we now continue and use these additional settings? One more query to look at to see the difference. So now it expands on the resources and also on the users, on the principals. We see that this service account, default service account, has the editor role assigned on the project, on the service account, and another service account, so it can impersonate other service accounts. And then if you take a look at the GCP admin, this guy is an owner of the project, of the default service account, which was created when I enabled the Compute Engine API, and also of this custom service account, which was created by this administrator. Okay, there is also the IAM service accounts get access token permission, what's associated with one of the service accounts on the custom service account. So as you can tell, there is really a lot of information, a lot of good information you can find inside of the output generated by this tool. One more thing I want to show you at this time is Policy Troubleshooter. This is something that we will use to really understand whether a principal can access a resource or not. Like what we saw with Policy Analyzer, the Policy Analyzer only applies to the allow policy to tell us, kind of like better visualize all of the bindings based on the different conditions across the organization and resources. Where with the Policy Troubleshooter, this is more of like a tool that we could use to kind of like simulate perform a simulation to see whether a principal has access to a resource at a given level. So this one is going to take into account all three types of IAM policies: principal access boundary, then deny, and finally allow. We will still need to provide information about the principal, resource, and permission. And this is something that we can access from the IAM and admin Policy Troubleshooter. Maybe before we use this feature, let's quickly go to the IAM page. And let's quickly create a deny policy for the training project. I'm gonna say don't prevent, or just remove, stop on VMs. This is gonna be the policy name. I wanna block access to the stop instance permission, and this is just for TAD. Compute Google APIs com instances stop. Just a single permission is what we want to block for TAD. No conditions. We could use conditions to be more specific, like to point to a single VM, but we will do this across the whole project. We go back to the allow policy. We see that SecOps that includes TAD has compute instance admin v1 assigned, so it means that TAD is going to be able to start, stop, delete. It is normally able to start, stop, delete instances, but with this deny policy in place, he shouldn't be longer able to stop the VMs. But instead of testing this, we want to use Policy Troubleshooter to figure out what is going to happen for TAD when he tries to access One of the VM instances, like let's go for instance 2 this time, training instance 2. And maybe let's first say compute images. Compute instances delete. First thing I want to see if that is able to delete a compute engine instance. Okay, so it gives us a summary of what we are looking at. That resource is VM, and this is a permission. We are essentially trying to see what is the end result when, again, TAT tries to access this resource using this permission. And the access state goes like that. First, they tell us that principal access boundary says I'm okay with that. An IAM policy has nothing to tell about this permission. And there is allow policy which permits access. So the result is that it says that is going to be able to do that. We can also take a look at the details here. So see the deny role. It says no deny. It says it only displays relevant details that explain why a principal is or is not denied. Okay, so we have a role, we have a policy, but it's not a match here. And if we take a look at allow policy, see binding details, we have access because of this role. You can also take a look at this in the JSON format. Okay, so we see that the deny rule, there is one that matches that, but it's for a different permission. So what about if we now change permission? If we say that we want to look at the stop action, assuming that the policy has propagated down across the cloud, we should see a no-go. Okay, so we see that principal access boundary is okay. Deny says no. Allow says okay, but since deny takes precedence over allow, the outcome is that we do not have access. Now, if we take a look at the details, we see that the principal TAD is, the permission compute instances stop is explicitly denied. This time the permission matches the role, and because of that, access is blocked. As you can see, you can use this feature to quickly check the amount of access a principal is going to have before you make a change to the IAM policy. And then after you decided to make this change, you can use this tool, rerun the query, and see if the change actually took effect without looking at this at the resource level.